A very good day to Dr. Zraini. Today our group 2 will present about the analysis of potential of solar energy in Thailand. For chapter 1 introduction, the background of the study. For an extended period, the primary energy source for transportation, heating and power was fossil fuel, but they are limited and cause air pollution. To mitigate environmental impact, it is essential to transition to the renewable energy sources such as solar power. Thailand, a Southeast Asian country with a population approximately 70 million, is increasingly adopting solar energy due to its abundant sunlight and decreasing cost of solar energy. Significant initiatives such as establishment of solar farms in Nahan, Rakasima, and also Lopburi have emerged as a result of the regulation and incentive introduced by the Thai government to promote solar energy usage. Aligned with the Thailand goals of establishing a low-carbon economy and ensuring environmental sustainability, this modification aims to enhance energy security, reduce greenhouse gas emissions, and promote economic growth by leveraging green technology. Next, problem statement. In particular, the high initial investment costs and the uncertainty of the subsidy for solar projects are highlighted in the article as an obstacle to the development of solar system in Thailand. These challenges make it difficult for individuals and communities to invest in photovoltaic rooftop or ground-mounted system, which is limiting the country's overall adoption of PV system. This situation is further complicated by the lack of certainty in the subsidy, as the ADER scheme, originally introduced back in 2007, was cancelled in 2010, and it leads to several years of disruption in solar energy power projects. Thus, to promote the development of solar energy power in Thailand and the transition to a more sustainable energy future, it is crucial to address this issue. Next, we're going to talk about the objective of study. First is to promote the production and use of electricity from renewable energy sources in Thailand through policy and incentives such as the Energy Service Company ESCO fund and other and feed-in tariff measure. Second is to standardize photovoltaic system and provide technical support for PV system. Third is to overcome the obstacle in developing solar energy system, such as the cost of early investment and subsidy uncertainties, to reach the target set by the Committee on Energy Reform for 20 years. The expected outcome of this study is to help Thailand to continue its effort towards establishing itself as a hub for renewable energy in the Asian region by addressing obstacles including the costly startup investment costs, uncertainty of subsidy, and the policy development. With the implementation of initiatives like the Thailand Solar PV Roadmap initiatives, and policies such as the Energy Service Company ESCO fund and feed-in tariff FIT measures, the country aims to achieve its target of generating 27.9% of electricity from renewable sources by 2036, with a specific goals of 6,000 megawatt from solar energy. A significant increase in the production of solar energy in Thailand, contributing to the country's renewable energy objective and the sustainable energy future, is expected as a result of the steady growth of energy solar capacity, supported by the government policy and incentive.
Hi, so my name is Maya. So let's move on to the literature review. So the first one is we got the inside the geographic and climatic potential. So this is about the high solar installation levels 5 to 6 kilowatt per day, and the proximity to the equator, and the stable weather conditions. So this is from the Prompton 88 L 2019 study findings. So next we got the regional solar potential. So geographic information system GIS. So we got analysis by Kittner ETAL. Central and northern regions have the highest potential. Is it the availability of land for solar farms? Next, we got the technological advancement. So it increased efficiency of photovoltaic PV panels and the development of bifacial and floating solar system and the technological innovations reducing costs. So next we got the government policies and incentive. Alternative energy development by plan at ADP. The goal is 30% renewable energy by 2006. The specific target is 6,000 megawatt of installed solar capacity by 2036. And the policies is the feed-in tariff and tax incentive. So next on, we got the challenges and barriers. So first one is budgetary constraint, which is the high initial capital cost, limited funding option for small scale projects. Next, we got the regulatory obstacles, which is complex and ambiguous regulations, and it need for streamlined permitting process. Next, we got the public acceptance and awareness. So it's like need for public education on benefits of solar energy. The next one is grid infrastructure, need for the upgrades to handle intermittent solar power. So the last but not least for the literature review is the case study, which is 73 megawatt solar power plant in Hon Rokasisma province. So it's the rooftop solar installation in Bangkok, and the last one is demonstrating viability of large scale and distributed solar generation.
Next part of this research is the methodology. The methodology of this study includes careful steps to achieve the objectives of the study systematically. The approach used in this task involves the formation of econometric model, variable measurement, and types of error in the diagnostic steps. This is the econometric model that is used to run the analysis of the study, where solar energy consumption is equals to trade openness plus human development index plus population growth rate, and finally plus urbanization population growth rate. The data for this analysis is collected from various articles and journals and also World Bank. So this study uses time series data covering 14 years from 2009 to 2002 with the data collected from the World Bank. It covers important events such as the Asian financial crisis, Thailand's entry into the World Trade Organization, and the global financial crisis. The data analysis techniques used in this research is correlation, ordinary least square, ADF, cumulative sum chart. Firstly, correlation. Correlation is used to measure the strength of the relationship between the variable as well as evaluate the relationship between the independent variable and the dependent variable. The use of this method provides a deep insight into the strength of the relationship between two variables, and the value range of this correlation coefficient is between -1 to 1. Next, ordinary least square. OLS is a method in multiple regression analysis that is used to minimize the error term in the estimating the regression line. OLS involves two variables, namely the independent variable and the dependent variable. To achieve the best estimate with the OLS method, 4 blue bases are required, namely best, linear, unbiased, and estimation. The following analysis technique used in this research is ADF. This augmented Dickey-Fuller test is a test for unit root in a time series sample. An augmented Dickey-Fuller test is a version of the Dickey-Fuller test for a larger and more complicated set of time series model. This ADF statistic used in the test is a negative number. The more the negative it is, the stronger the rejection of the hypothesis that there is a unit root at some level of the confidence. Next is the cumulative chart. A cumulative sum chart is a type of control chart used to monitor small shift in the process mean. It uses cumulative sum of deviation from the target. The Kusum chart plots the cumulative sum of deviation from the target for individual measurements or subgroup means. When designing this chart, it is necessary to consider the average run length and shift to be detected. Extensive guidance is available on suitable parameter. It is possible to modify the Kusum so it responds more quickly and detect a process that is out of control at startup. The modification is done using an initial Kusum equals to half of the parameter.
Solar energy consumption shows upward from 2009 till 2019 and then dropped from 2020 till 2022. Human Development Index shows the upward trend from 2009 till 2022. GDP growth shows the upward trend in 2009 till 2012 and then dropped from 2013 till 2020 and increased back till 2022. Trade openness shows the decreased trend from 2009 till 2012 and then increased from 2013 till 2020. After that, it decreased till 2022. Population growth rate shows a decreasing trend from 2009 till 2022. Descriptive statistic. Trade openness has the largest maximum value, which is 129.68. GDP growth has the smallest minimum value, which is negative 6.07. Trade openness has the largest data spread out, and Human Development Index has the smallest data spread out. For skillness, solar energy consumption, Human Development Index, trade openness, and GDP growth have the negative skillness because the value is more than negative 0.5. Population growth rate has the asymmetric skillness because the value is between negative 0.5 to 0.5. Urban population growth rate has the positive skewness. Solar energy consumption, Human Development Index, population growth rate has the light tail because their kurtosis value are less than 3. Correlation. From the table above, it shows for the solar energy consumption has the strongest positive relationship with non-human development index and strongest negative relationship between urban population growth rate. For non-human development index, it has the strongest positive relationship with non-solar energy consumption and the strongest negative relationship with population growth rate. For non-GDP growth, it has moderate positive relationship with trade openness and the weakest negative relationship with non-human development index. For trade openness, it has the moderate positive relationship with the non-GDP growth and population growth rate, and the moderate negative relationship with non-human development index. Population growth rate has the strongest positive relationship between urban population growth rate and the strongest negative relationship with non-human development index. Urban population growth rate has the strongest positive relationship with population growth rate and the strongest negative relationship with non-solar energy consumption. Ordinary least square. The table above shows the urban population growth rate and non-human development index has significant at 1% and 5%. There are 93.67% of variation non-solar energy consumption can be explained by variation non-human development index, GDP growth, trade openness, population growth rate, and urban population growth rate. F statistic is not significant at 5%. Unit root test. For non-solar energy consumption, it has 1% significance at level intersect, and trend, and first difference intersect and trend. For non-human development index, the highest significance is at 5% in first different intersect. For GDP growth, the highest significance is at 1% at first different intersect and trend. For trade openness, the highest significance is at 5% at first different intersect. For population growth rate, the highest significant level is at 10% at first different intersect. For urban population growth rate, the highest significant level is at 5% at first different intersect and trend. Kusum test. On the graph above, it shows the line didn't cross the red line, so means that it is stable.
In conclusion, the factor that affects solar energy consumption positively is the Human Development Index. The higher the Human Development Index, it leads to better adoption and use of solar technologies due to improved education, healthcare, and living standards. The factors that affect solar energy consumption negatively are foreign direct investment, trade openness, and also urban population growth rate. As for foreign direct investment and trade openness, they may divert attention from solar energy. Urban population growth rate may strain resources and infrastructure, limiting renewable energy investment. Urban population growth rate also bring challenge of expanding solar infrastructure. Recommendations for the barriers are enhancing the R&D, research and development to stabilize and advance the solar technology, ensure the policy stability, also integrating solar energy into urban planning and infrastructure. However, further research could also explore additional and mechanisms that affect solar energy consumption. That is all from us. Thank you for listening.